All right, so this is for pages 12 and 13 of the running test. It starts with central tendency, and then the last part that we're working on is quadratic, these graphic quadratics. So the first few questions deal with a set of data. Normally you get a set of data, and the first thing you would do is put it in order. Just to save time on the review, I put them in order for you, but you should know that you need to put them in order in case they're not. Finding the outlier, if you look at all the data, all these numbers are relatively close together, and then you have one that's way off. So the outlier is most definitely 22. So you're really not going to use that outlier when you go to calculate all this other stuff. So calculating a mean, by now I think you all know how to do that. A mean is simply an average, to add up all these numbers and divide by how many there are. When you do that, you come out to 4.1 as a mean. The median is the middle number, so we actually want to look at all of these and say there are 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. We want the middle of that, so there would be 4 on this side and 4 on this side. It turns out that the median is this 5 right here. So the median is 5. And the mode is the most frequently occurring number, which is also 5, as you can see. So standard deviation is the one that takes a little bit of work, but it's also probably the most important statistics tool you can use. It tells you how good the median really, or the mean, really is. So the first thing you're going to do is take all of these numbers and find out how far off they are from the mean. So for example, the number 1 is 3.1 from the mean. And 2 is 2.1, and so on. So I'm just going to do this for all of these numbers real quick. You can use a calculator if you need to, although I think in this case the numbers are pretty easy to deal with. So hopefully you don't even need a calculator. That's what we get when we find the average, the distance, the difference between each one of the data points and the mean. All right, the next step is to square all of those. So you literally have to square each one of these numbers. So like 3.1 times 3.1. If you do that, you get 9.6. And again, I'm just going to give you the solutions that I got for each one of these numbers when I square them. Your next step is to find something called a variance, which is basically the mean or the average of all of these numbers you just got. So you're going to add them all up, and again, divide by 9, because there are 9 of them. When you do that, the variance comes out to 3.65. And your last step is finally to do what they asked you to do, which was the standard deviation. The standard deviation is the square root of the variance. So we're actually square rooting 3.65. And so our final answer for standard deviation here is 1.91. That's actually a very low standard deviation, which means that the numbers are relatively close to the average. If you look at it, none of these numbers are really any more than 3 places away, so that tells you they're awfully close. Imagine what would happen if you put the outlier in the data, how much different it would be and how much it would affect the average. It would make it go way up, and it would make the standard deviation go really high too, because then you have a number in there that's way far away. And so with an outlier in the data, what happens is it really skews the data off. It makes it seem like the data is really bad, when in actuality it's really not that bad at all. It's actually quite close, but the standard deviation reflects that outlier in there. So when you calculate it, usually you leave the outlier out, which is the whole point. All right, so now it says to make a box and whisker plot for this data. So box and whisker is all based on medians, not average. So I'm just going to make a quick number line here. And my numbers are going to go from 1 to 7, so I don't have to have a whole lot on here. I'm just going to start at 0 and go up to 7. And over here, even though we're not going to use the outlier in the calculating part of it, you do need to include the outlier in the box and whisker. So you break the line like this. to show that you don't need any of the numbers between 7 and 22. And we'll get to that in a minute. So let's take a look at how to actually draw the box and whisker. Well, I'm going to rewrite that data set down here, just so we can look at it right with our problem. Okay, this is the data I'm going to work with. The first thing I would do is find the median of the whole thing, which we already did, which was this 5. So we're actually going to put a line on the box and whisker right where that 5 is. Now I need a median for the lower half, which would be right in here. It would also be 2. 2 plus 2 is 4, divided by 2, we get 2 anyway. So it's right here. And we also need a median for the upper half, which would be here. 5 plus 6 is 11, divided by 2, that median is 5.5. You actually have to go to the graph and put in where 5.5 would be, which is right there. Now you can draw the box. And the only thing you need now is the lowest point, which is a 1, put a dot there, draw the whisker to it. And the highest point, which is 7, so put a dot there, draw a whisker to it. So basically you're done with the box and whisker plot, except you do need to show that there actually was an outlier in the data. So we don't use it in any of the median calculation or anything like that. All we do is put a point out here where the 22 is to show that there was an outlier in the original data. That's a complete box and whisker plot. Alright, so this time I'm actually giving you a box and whisker plot and asking you to answer questions about it. So for this one, it says that the box and whisker plot represents 28 students' test scores on a test that's worth 30 points. Okay? So the first question says, what's the median? The median is always this line in the center of the box or somewhere inside the box. It looks like it's right above 24. So our median is 24. What's the interquartile range? Inter means between the quartiles. So here's the first one, and here's the other one. It goes from 20 to 27. That means the interquartile range is 7. What range of numbers represents the bottom 25? That's the left whisker. So the left one goes from the lowest 16 up to 20. So this answer would be 16 to 20. What was the minimum score needed to be in the top 25? That represents up here. This is the top 25%. So just to emphasize, this is divided into 25% here, 25% here, 25 here, and 25 here. So the top 25% is the right whisker, which means you needed at least a 27 to be on this side. So the answer to this one was a 27 out of 30. How many students scored the top 25%? Now it's actually asking you for the number of students. Well, all you know is that the top 25%, well, that's 1/4 or 25% of all the students. So you actually take 0.25 times 28, and you get 7 students. Okay, what's this a good test? Well, it tells you on your repacket that did at least 70% of the people pass it, show proof. Well, what's a passing score for a 30-point test? 0.66 times 30. And you get 20. So it means to pass, you needed at least a 20. Well, if you look at it right here, here's the median at 24. That means 50% of the people were higher than 24, so at least 50% passed it. So let me go down here. This is the bottom 25% right here. This means right here 75% and above. So actually where 20 is, the passing score, it says 75% of the people scored better than the passing score. So we would say, yes, it was, because 75% scored higher than 20. And 20 was passing. Okay, and then it says if the average score was 23 out of 30, would you say that the standard deviation would be high or low? Well, 23 out of 30 means right in here is where the average is. If that's the case, you know, you go down to 16, you go as high as 30, but you don't have anything really crazy out there. There's no like 50 out of 30 or 0 out of 30 or something like that. It's way off. I mean, basically you're saying it's within 8 numbers on the low side and 7 numbers on the high side. You know, that's pretty good. That's relatively close data. So I would say the answer to this one would be at least relatively low. And that's because there are no really crazy outliers or any data that's really, really spread out. You know, if this whole thing was all the way down here, like that, then I could see it. But you're talking about data that's all relatively close to where that average would be. So your answer to this is relatively low. All right, that took care of central tendency. Now we're on to graphing quadratics. This is the last part of the running test. These seem to be kind of like a mixed bag. Some people find them relatively easy, some find them more difficult. So I'm going to try to take you through it step by step. It'd be great if you had your notes right there so you could follow this, so you can see that this is the exact same thing you would have done in your notes. A for this would be -4, B would be -8, and C would be -3. Following the pattern of A is the number next to x squared, B is the number next to x, C is the one by itself. Okay, so the next step for doing this would be to decide whether it's going to be up or down. Because A is negative, this is going to be a downward graph. It's going to look like this. And now to find the axis of symmetry, we do x equals -b over 2a. For this problem, b is -8, so it's negative, -8, and then a is -4. So we actually get it +8 over -8, which is equal to -1. So we know for this problem that x is -1. Okay. Now I would find the vertex. The vertex is to take this answer for x and put it back into the equation. So it would be -4 times -1 squared minus 8 times -1 minus 3. So we can work this out. -1 squared is 1 times -4 is -4. This is going to equal +8, and this is going to be -3. We put that all together, and we got -4 plus 8 minus 3. It's going to be +1. So our vertex point is the -1 we had for x, and the 1 we got as an answer. Excuse me. It looks to me like we're going to be able to scale this graph by 1, so it shouldn't be too bad. Before we go to the graph, let's do the y-intercept while we're at it. That's just equal to whatever c is, so our y-intercept is -3. Okay, time to go to the graph. So let's just draw an x and y axis in here. And let's go back and put some of this stuff on. All right, the axis of symmetry tells us to put a vertical dashed line where x is -1. So here's where x is -1. We need a vertical dashed line right here. When you're doing this on a test, you should have a ruler and make these things nice and straight. All right, you have a vertex point, the first one we found, -1, 1. The vertex is always on the axis of symmetry, -1, up 1, so right here. And our y-intercept is at -3. So we can put that point on here. On the y-axis, where is -3, right there. And it has a twin point on the other side. This one is 1 block away, so it's 1 block away over here. You can kind of see what our graph is going to look like. It's going downward like that. So what I would suggest is, let's find one more point so we can shape our graph the correct way. So the question is, where is it? If you look at the graph, right, you know what you want is a point somewhere over here or over here, somewhere in this area or this area, to help you figure out where exactly to draw the rest of this curve. So if I'm trying to find a point that I'm guessing is down here somewhere, I don't know, but I'm guessing. Well, what's the x-coordinate for this area? If I trace it back up, it looks like this is where x is 1. So then I'm trying to figure out where it goes down here. So I'm just sort of taking a guess on what I think the point would be. But I'm going to guess that I'm going to use x as 1. So I'm going to go back over here. And I'm just going to say, if x is 1, then I'm going to put it into this equation and see what happens. So it's negative 4 times 1 squared minus 8 times 1 minus 3. So let's see what I get here. 1 squared is 1, that's negative 4. This is negative 8. And that is negative 3 again. We're going to get a kind of a big number here, but it happens. This is going to be negative 15. So the point is 1 from a negative 15. That's a lot. We might not even be able to make it fit on our graph. I don't know. 1, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yeah, we're way, way down here. So, I can fix this. Not too much of a big deal. Let's just make it fit. That dot was supposed to be at 1, negative 1. These were supposed to be negative 3. So I'm just fixing my graph so that I can show you how it fits. Actually, it's supposed to be negative 1, 1, so I got to move it. Okay, so our graph seems to be all right now. So now we have to put the point 1, negative 15. So we're in this column, and we got to go down 15 places. That's 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, all the way down here. 2 blocks off on this side, twin is 2 blocks off on this side. So you can see we've got a really long, stretched out graph. But again, that happens with quadratics. So you're basically done with all the points you need. Now you've got to try to make this thing connect somehow. So big, it's probably going to look really kind of funny looking, but we'll do the best we can. Well, there are other ways you could have made this work. Maybe we could have tried to find a point up in here and use 0.5 or negative 0.5 or something. But, you know, this just makes it a little bit easier dealing with numbers that are easy to work with. So your final thing will be that what is the max and what is the min? The max for this one, it reaches this height and then stops. That's a point that is positive 1, and the minimum goes on to negative infinity. These arrows go on forever. All right, so we have this next one, which is a pattern similar to the last one. So let's see what we get with this. Okay, so this one we would say A is 1, and understood 1. B is negative 3, and C equals 4. This graph is going to go upward, because A is positive. And our axis of symmetry would be negative of negative 3 over 2 times 1. We're going to get 3 over 2. Might as well make it a decimal, 1.5. So that already tells me that I might want to scale my graph a little bit differently, but we'll get to that in a second. Let's do a vertex. So vertex, stick the 1.5 in for one of these. And now we know actually 1.5. So I'm going to say 1.5 squared minus 3 times 1.5 plus 4. I'll use a calculator real quick for that. If you want to use a calculator, make sure that you put the stuff in parentheses like I did, and then make sure that when you put it in the calculator, you include the parentheses such that you are typing it exactly how it's written, and you'll be okay. Comes out to 1.75. So what I have as a coordinate point is 1.5, comma 1.75. And I know the y-intercept is equal to 4. So with that, I'm going to go to my graph. Yeah, I know this graph is going to open upward, so I'm going to give myself a little bit of leeway here and make it so that I'm really only looking at the top part of this x and y axis. So I'm going to do that. The other thing I'm going to do is I'm going to scale the graph so that I can put decimals on it like that. So I have stuff from 0.5 and 0.75. Well, I'm going to make it by 0.5. So each block is going to be worth 0.5. So this would be a 1, 2, 3, 4, 5, 6, 7, like that. And over here also by 1. 1, 2, 3, 4, 5. So every 2 blocks is worth 1. In other words, every block is a 0.5. So let's put the axis of symmetry in at 1.5, which would be right here. Vertical dashed line where x is 1.5. Let's put the vertex point in there, over 1.5, up 1.75. So here's 1.5, here's 2. I need it to be right in between them, so I can kind of estimate a little bit, right there. And the y-intercept I got was at 4. So we need to put a point at 4. Okay, it's 3 blocks away on this side, so I need its twin point to be 3 blocks away over here. Okay, here's the situation where you're trying to find that last point so that we can get 2 more points on here and really shape the graph. I would say that a lot of people look at this and say, well, I can just go out to 4 and I'll find another point out here somewhere. And that's probably true, you could. I would also say that if you look at it, right, you know there's a point in here too. So if I chose the number 2, I get a point that lands in this area somewhere. I can choose 2 for x. So that's what I'm going to do. I'm going to choose 2. So I go to the equation, I put a 2 in there. So 2 squared is 4. This is 4 minus 6 plus 4. And that looks like it's going to give me 2 as an answer. So I actually have a point that is 2 comma 2. All right, back to the graph. Let's put 2, 2 in there. Over 2, up 2, right there. 1 block away from the line on that side. 1 block away over here. Now we've got an image of what this graph is going to look like. Kind of a fat-shaped graph this time. And so for this one, our maximum is going to go off to positive infinity, and our minimum goes this far, and that's it, which looks to be 1.75. 1.75. And so we're down to the last 2 questions. It says, what is the name of the type of graph in part A or B? Well, when we did linear equations, we said the name of the thing you graph is a line. We do quadratics, the name is a parabola. And how can you tell whether or not a function equation is a quadratic? What you're looking for is to find an x squared term in the equation somewhere. And it has to be the highest power. And it's the highest variable exponent. So I could give you a couple examples. Let me show you one like this. This, and we have this, and let's do one more. So if I was asking you about these three things, I would say this one is the quadratic. Because if you look at this one, it doesn't have an x squared in it at all. That's a linear. This one has an x squared in it, and it's the highest exponent with a variable like that. That's good. This one also has an x squared, but there is also an x cubed, which means that this one is not quadratic because the x squared is not the highest exponent, the x to the third is. So this is an explanation of what makes a quadratic a quadratic. It's either x squared, and it has to have that, and it also has to be the highest exponent on any variable. All right, that is it for the review for this point.